Hello guys, welcome to the next part of the authentication wherein we will be studying what is the message authentication code. In the previous lectures we have seen what are the authentication requirements, what are the authentication functions. Also we saw what are the different types of authentications which can be used to prove the identity of the users, and now we will be studying a new concept, that is the message authentication code, which is then appended with the message to prove its identity, to prove the user's identity. Cryptanalytic attacks can exploit structures like block ciphers want the brute force attacks to be best alternative. More variety of MACs, so harder to generalize about cryptanalysis. We all know what the concept of cryptanalysis is. So more variety in the message authentication code will then lead to, you know, um, it then leads to difficulty wise. You cannot have the idea of what the MAC is all about. It becomes very harder, it becomes very difficult for the attacker, it becomes very difficult, infeasible for the intruder to guess what the MAC can be, and then you can easily avoid the cryptanalysis type of the attacks. Keyed hash functions as the MACs want a MAC based on the hash function because hash functions are generally faster. Crypto hash functions code is widely available. It is easily available. You can easily have that crypto hash functions which can be then implemented to enhance the security of your message. Hash includes a key along with the message. Original proposal is like this: keyed hash is equals to hash which is being implemented, that is the hash functionality is being implemented on the key and the message. Some weaknesses were obviously found with this, that is eventually lead to the development of secured MAC, that is hashed MAC function. And now we'll see what is the problem with the keyed hash. Keyed hash that is achieved by implementing the hash functionality on the key along with the message. Just recall the hash functions works on the block. We have the block ciphers. Let's suppose M is the plain text message, key, message padding, and M. So M is then calculated as the combinations of M, M1, M2, M2 till the ML, where MI is the block size, H is the hash functionalities to be implemented upon the different number of the blocks of the plain text. So sometimes it becomes very problematic to properly have the keyed hash functions, and it sometimes becomes the problems to properly implement the hash functionalities on the plain text messages, but can add with the extra blocks by adding ML plus 1, which is considered as the extra block of the plain text message. And then we can implement hash dash by using the hash on the hash of the added block of the plain text message. So if there is a problem with the keyed hash function, then it can be reduced to some extent by using the hash dash, which can be then implemented on the hashed messages. Unless formatting prevents it, exactly, unless formatting prevents this addition of the extra block, we can resolve this problem to some extent, but then also it becomes somewhat difficult. So it is better to use HMAC instead of MAC. Thank you guys. I just hope that you might have understood the concept, the basic concept of message authentication codes. In the next lectures, we'll be seeing HMAC, we'll be seeing CMAC, which will then again help you to learn to get the concept of why the message authentication codes are then used, why the hashed functions are then used to provide or to enhance the security of your encrypted messages. Thank you once again.